The Ray approximation in ray optics. When we have plane waves, as you can see, the wave fronts are planes traveling in a certain direction. We can represent this by a set of rays traveling perpendicular to these plane wave fronts. And there are three possible outcomes when these rays are incident on an opening or a slit. And the response depends on the width of the slit compared to the wavelength of the light or the waves that hit the slit. So the first possibility is when lambda is much less than the diameter or the width of the slit, the rays continue in a straight line path and the ray approximation remains valid. So as you can see, these rays are basically traveling undisturbed by the slit on this linear path. So we still have the plane wavefront. So the plane waves, when they pass through the slit, are also plane waves for a slit opening or slit width much greater than the wavelength of the waves. Now, when the wavelength is comparable to the slit width, the rays spread out after passing through the opening. So we no longer have plane waves. Basically, we have these spherical wavefronts. So you can see that they are spreading out. Another extreme is when the slit width is so small, it's much less than the wavelength of the waves, incoming waves. The opening will behave as a point source emitting spherical waves. So now we have only one point here that is basically creating these spherical waves. So we get the best approximation to spherical waves by using a very narrow slit. So when light travels through a uniform medium, when we don't have any changes in the medium, it moves on a fixed straight line that's called the ray or geometric optics, which is perpendicular to the wavefront. So that's what we have here. The wavefront is a plane and the light is traveling perpendicular to the wavefront in a uniform medium. That's ray optics or geometric optics. When the diameter of the opening, the slit width, is much greater than lambda, the ray approximation holds and we still have the light moving in a straight line. When the diameter of the opening is greater than or comparable to the diameter or the width, the light wave spreads out and the opening acts as a collection of point sources of waves. So basically, this we will see is actually the Higgins Principle. So you can think about having several points here in the slit and each point is acting as a point source, and as a result of the interference of the waves coming from these point sources, we create this effect. So we have the light spreading out. So when light spreads out or a wave spreads out when it is incident on a slit, this effect is called diffraction, which we will talk about in the upcoming lectures. Okay, so in summary, we're talking about the ray approximation. Ray approximation means light traveling through a uniform medium will move on a straight line perpendicular to the wavefronts. And this ray approximation holds for a slit opening much greater than the wavelength of light, but when it is comparable to the wavelength of light or less than the wavelength of light, we have the spreading effect. In the extreme case, when it is much less than the wavelength, the slit acts as a single point source emitting spherical waves. This effect we call diffraction.